I was in a TikTok live last night where someone kicked me out because I corrected them about the atmosphere of Mars, which is actually a far more interesting topic than you might think. So hello, my name is Zeta. This is my physics degree. Let's talk about it. Now, the claim that I was disputing was that Mars has a thick atmosphere thicker than Earth's, which ultimately is not true. So Mars, fourth planet from the Sun, about 1/10 the size of the Earth, has an atmospheric pressure at sea level about 1% that of Earth's. The other way you can look at this is that the max density of the Martian atmosphere is about 2% the max density of the Earth's atmosphere. However you want to look at it, 1 cubic meter of Earth atmosphere versus 1 cubic meter of Mars atmosphere, you're going to have about 100 particles of Earth atmosphere for every 1 particle of Martian atmosphere. Mars has a very thin atmosphere, which is a pretty simple statement in and of itself, but it brings us to a cool bit of science. Now, one thing you might have caught is that Mars has an incredibly thin and small atmosphere, that it's also one that we can't breathe. It's 95% carbon dioxide, 3% nitrogen, 1.6% argon, less than 1% all the other stuff. Which might bring you to the question of why are we looking for signs of past life on Mars? And it's because we're pretty sure Mars used to hold life. It used to have a much more Earth-like atmosphere. Which begs you to the question, what do we think happened? And the leading theory is that Mars lost its electromagnetic field. So all of the metals and stuff slishing around inside the Earth creates a magnetic field that protects us from what's called the solar wind, which is just charged particles that fall off of the sun. Mars doesn't have that same electromagnetic field. Its core, we believe, is inactive. So it doesn't have anything to protect itself from all of those charged particles from the sun. So the solar wind can just whip right through Mars and strip away its atmosphere. Now, this isn't something worth studying and that we need to be concerned about it happening on Earth anytime soon. Pretty sure we're probably good. Weird stuff does happen, but we should be good in that regard. But it is definitely worth studying, and that it is a different window into how planets can evolve in different ways, even when they start from somewhat similar places. It's also interesting to consider in that we have to send people to Mars at some point. Well, don't have to, but we're going to. We're certainly at least going to try. And how do you counteract that? How do you help protect astronauts or even future colonists from different radiation that the Earth just naturally protects us from? Can you ever terraform Mars, knowing that you would have to fight against that solar wind to regenerate and maintain an atmosphere? And it's just, to me, a really interesting, small, tiny little thing that shows how the universe isn't static and how it's constantly evolving and all of the different factors at play when we're trying to look at moving out into space and studying the universe around us and our place in it. Testing to see if my audio is still going to be whack as fuck, because if it's not, I'm not going back to fix this, and I'm sorry if you had to watch all of this with super shitty audio.